students, welcome to IMS Get Academy. But this is the second session for electronic devices and circuits. In the first session, I have done around 12 questions, I hope it now. Some students reacted very well. But if you have the friends, please try to share this link and ask them to attend the session. Understand now? Yes, we can start the session now. This is the first question from EDC. Anybody can tackle this question? But I want to give in your hand at first. Anybody can tackle this question? Consider a P-silicon mass capacitor in strong inversion condition given Na equal to 10 power 17 per cm cube, Ni equal to 1.5 into 10 power 10 per cm cube, Kt equal to 0.026 electron volts. Epsilon for silicon is given 11.7 times of epsilon naught. Epsilon naught is given 8.85 into 10 power minus 14 farads per centimeter. The surface potential is dash volts. Is asking to find the surface potential. Anybody can do this question? May I know how many number of students are present in this session? May I know that? Yes, I will do the problem now. Please watch. What is given in the problem? Please try to note down there. The data you try to note down here now. Na is given 10 power 17, no doubt. I'll write again now. Okay, anyhow it is given. Acceptors concentration is given in the problem. This is acceptors concentration is given. Intrinsic concentration given. But how we can measure the surface potential? Surface potential is denoted by letter phi suffix S. I can put here now. Phi suffix S we can put here now. Surface potential. This is from the mass capacitor. How surface potential is calculated? 2 into phi of F they will use. Surface potential is calculated by 2 into phi f. This is for the what? Strong inversion only, this formula. This is applicable for the strong inversion. Here specified clearly. For strong inversion you can apply. Inversion. The Fermi level potential is given phi f. But how to find the phi f? That is more important again. Phi f is calculated by Kt into, that means 0.06, Kt into ln of, they will apply Na by Ni, acceptors concentration by intrinsic concentration. By using this formula, you can determine phi f here now. Phi f is calculated by this particular formula one now. So when you want to find the phi s surface potential, you should apply to phi f, where phi f equal to Kt into ln of Na by Ni only now. But you substitute the values and give answer. You substitute the values. How we can substitute? Kt is given here now 0.026. 0.026 I can write clearly. Ln of log of Na is given in the problem 10 power 17 it is given divided by Ni. Intrinsic concentration is given 1.5 into 10 power 10 is given here now. 10 power 10 is given. Now you can determine phi f. Phi f is calculated here now. How much this value? Anybody can use calculator. What phi f you are getting, you check it. Anybody can give? What phi f you can get here now? What phi f you can get here now? Its value will be phi f is nothing but 0.40 0.4081 volts possible. 81 volts possible. 408 volts possible now. That much voltage possible. Once you are getting the phi f value, you can determine the surface potential directly. Phi s you can calculate now. I want phi s. Phi s equal to 2 into phi f, you know very well. The 2 into, I can multiply 2 into 0.408. Then phi s is calculated as, phi s value is nothing but, it comes as 0.816. 0.816 possible. That much potential is possible. It comes in volts only now. It comes in volts. This is the solution for this question. This problem is from the mass capacitor. Understand my point now. I think you followed clearly now. Understand now. Shall I go to the next question? Yes, the next question is, the next question. You please start doing this question. You try to do this question. Before going to the next problem, just I want to give you some information regarding the IMS GATE Academy. The students can join our Telegram channel. The link is given in the description only here now. But if the student join in this Telegram channel, what benefits they can get now? But first of all, the schedules of the free YouTube lectures information you will receive. Any YouTube sections are conducted on the what now, white shoe. Immediately the schedules will be given in this particular Telegram channel now. The students can get the dates and everything, and they can watch white lectures only. And also lecture PDFs are available. They will get the lectures PDF. That means I am teaching the what now. I'm doing the what now EDC. Once this the today's session is over, the PDF for the what now, this lecture will be posted in the Telegram channel only now. Students can watch that PDF. And important dates related to the seminars and webinars will be given. The PSUs and other government job notification also given. Expert session on important topics, daily quiz also conducted. Good questions are posted in the Telegram channel. The students can attempt those questions now, and they can improve their knowledge also. Suppose they are able to do the question you think it's the now. They will get the solution for the questions also. That will be posted in the Telegram channel now. Understand of this? The advantage is there now. The students can join in this Telegram channel now. Understand my point now? Next one. The students who wants to take GATE coaching for 25 and 26, they can take the admission in IMS GATE Academy, those who are interested. Sir, here available live and online classes program only now. What are the features of this program? 800 hours of live classes with live interactions possible now. The theory book, exercise books, and 30 years GATE questions banks with video solutions given here now. The students will be given exercise books that contains around 4,000 questions are there now. And 30 plus years of the GATE questions, 30 plus year GATE question banks with video solution possible now. The student can prepare only these questions only now. Not required any textbooks, I said now. Not required any textbooks now. Every information they are going to get only from the theory book and exercise book and 30 years GATE courses now. Up to that extent, if they are prepared, success easily they can get only now. 12 personalized one-to-one mentorship sessions possible now. Why this mentorship session is required? The students wants to get the guidance, how to prepare, and also, what way, how many hours they need to prepare for the what now, preparation of the any subject, and what are the important topics, and on what those topics they need to pay the more attention, and every information they will get from the what now mentorship session only now. 130 plus online tests with video solutions of the mock test and many more possible here now. The students wants to talk to the management. Here given the what numbers here now. The students wants to talk to the what now? Concerned people, I said now, concerned people. Numbers are given. Directly they can call and they can get the information regarding the gate. Understand now. Okay then. Come back to the subject now. Yes, this is the problem. Anybody can do this question? Any student can do this question. Are you getting solution for this question? What is given in the problem? A uniformly doped NPN bipolar transistor. Transistor is given. This is the question from the transistor. What type of transistor? NPN it is given. Has the following parameters. Ne equal to 10 power 19 per cm cube. Nc equal to 2 into 10 power 18 per cm cube. Nb equal to 10 power 18 per cm cube. De is nothing but 7 cm square per second. dB equal to 14 cm square per second. DC equal to 13 cm square per second. Xc is nothing but the 0.9 micrometers. Xb is nothing but the 0.6 micrometers. The emitter injection efficiency, gamma is given, gamma asterisk is the right word. Generally, some people will write gamma, but exactly means gamma asterisk is correct. Understand now? Emitter injection efficiency required now. But what is Ne here? The concentration at the emitter, concentration existing in the emitter only, concentration existing in the collector, concentration existing in the base also given here now. What about DE, DB and DC? Diffusion coefficient values are given. Diffusion coefficient at the emitter is given 7 cm square per second, for base and collector also given. Xc and Xb and are nothing but the emitter, what now, the emitter and base and collector you got now. That length of the what now, emitter, length of the what now, that base given here now. Understand now. But you need to know the formula of emitter injection efficiency, gamma formula required by using the internal parameters now. Once you know the internal parameters formula, easily you can tackle this question. Where the problem is going to arise means, if you don't have an idea about the formula, you will face the problem only now. Once you know the formula, directly you can use the calculator and you can get the solution easily. Just I will give, you try to muck up this formula. Mug up, understand my point now. What formula we can use for emitter injection efficiency? The solution I will write here now. Emitter injection efficiency required. This is denoted by symbol gamma asterisk. I can give. Generally they will write gamma asterisk. What formula is applied here now? That formula is nothing but 1 by 1 plus NB by NE into DC by DB, sorry, DE by DB, sorry, DE by DB into DE by DB into XB by XB by, they will use XE only now. By using this formula, emitter injection efficiency is calculated in the BZT. So directly you can substitute all the values. All these values are given in the problem itself now. So where we are going to face the problem in this question means just the formula only now. Once you know the formula, it becomes very simple. Just substitution of the values only now. Yes, we can substitute these values. Gamma asterisk is required. 1 by 1 plus NB. NB is given as a 10 power 18. 10 power 18 divided by NE. NE is given 10 power 19 is given. Into DE is nothing but 7. And DB is nothing but 40 unit is given. into XB is nothing but 0.6 micrometers by XC is nothing but XC 0.9 micro cancel here now, 0.9 is possible now. Use calculator and give the value. Use the calculator. Any student can give answer for this. What answer is possible? If you want, you can simplify like this now. 1 plus 10 power 18 by 10 power 9 is nothing but 1 by 10 is possible here now. 1 by 10 equal to 0.1 is possible here now. 0.1 only possible here. 1 plus 0.1 into 7 by 12. 7 by 12 is nothing but 1 by 2. 1 by 2 is nothing but 0.5, you know very well. 0.5 you can use. And 0.6 by 0.39. 0.6 by 0.9 means it comes as a 0.67 is possible. 0.67 is possible. If you are using the calculator, it comes as 0.967. 0.967 is possible. This is the value of emitter injection ratio. Such a way we can calculate. Follow this? Only you need to mark up this formula. Otherwise you can't do this question. Okay, you try. I will give one more question in your hand. This is question number 3. Anybody can do this question? I think the students will not face in doing this question. Start doing this question. But I want to wait for some time. You please start doing this question. Can you try this question? Yes, I will explain now. In bipolar transistor biased in the forward active region, let me see, bipolar transistor, not in bipolar. A bipolar bias, transistor bias in the forward active region. The base current IB equal to 45 microamperes and collector currents is IC equal to 2.6 milliamperes. The alpha is asking to find alpha value. What is alpha? Alpha equal to, you know very well, is the current gain, forward current gain. That comes mostly in which of what now? Configuration. In common base configuration, you will find the alpha only now. So just you try to recollect the formula from the common base configuration. You can do this problem very easily now. I'm writing the data, please note down. You try to understand. In bipolar transistor, that means bipolar, the bipolar transistor is given here. It is in forward active region. Forward active region means what is the meaning here? What is the meaning of forward active region? The transistor can act as a amplifier only when it is in forward active region only now. You know the modes of operations of the transistors: cutoff region, saturation region, active region. Only when the transistor is in forward active region, you can find the BJT to be acting as an amplifier only now. Otherwise, it won't act as an amplifier only now. So when it is, that means when it is, now it is acting as an amplifier only now. In this case, base currents and collector currents are given. Is asking to find the current gain, how much? Alpha value is asking to find only now. But here given base current is given in the problem clearly. Base current is given in the problem. Anyhow, I will write understanding purpose. base current is given. How much? 45 microamperes, no doubt. And collector current also given in the problem. IC is given 2.6 milliamperes only. Is asking to find alpha value. What is alpha? But you know very well, IC and IB is given means you can find the beta value very easily now. The formula for the beta is nothing but IC by IB. Once the beta value you are getting easily, you can determine the value of alpha. Alpha is nothing but beta by 1 plus beta, you know very well. This concept is more important. I say, you try initially for beta. IC by IB, I can write. IC by IB, collector current by base current. The collector current is given in the problem clearly, 2.6 milliamperes. And base current also given in the problem. The base current is given 45 microamperes. 45 microamperes of current is given. Then you can determine beta value. Its value comes as 57.7 possible here now. 57.7, that much value possible. You know very well, practically the beta value lies in between 20 to 500 only. Yes, within that range only we are getting here now. Understand now. Once the beta value we got, alpha is calculated very directly. Alpha equal to, you know very well, beta by 1 plus beta. Beta by 1 plus beta. You can use that. Beta is nothing but 57.7. 57.7 here now. Divide by 1 plus beta, 57.7 we can take now. Yes, you calculate what is alpha value here now. It comes as 0.9829. That is approximately equal to 0.983 we can write now. Approximately equal to that much. Here the four options are given. Which option is correct? Which option is correct? 0.983 means option B is correct only now. Option B is correct for this question. Such a way, the problem is to be tackled. It doesn't take more time only now. Understand? Yes, I will go to the next question now. Followed? If anybody having any doubt, you can ask. The next question is, this is the next question now. Yes, you try this question initially. You make an effort to get answer for this question. Initial work is yours. Initially, you try this question. This question is from MOSFET. From the MOSFET, this question was given. Numerical question. Yes, what is given in the problem? The drain of an N-channel MOSFET is shorted to the gate so that VGS equal to VDS. VGS and VDS are equal. The threshold voltage VT of the MOSFET is 1.1 volt. The drain current ID is 1.3 milliamperes. For VGS equal to 3 volts, then VGS equal to 5 volts, ID equal to how much only now? Catch my point. What is given in the problem? You try to catch. You'll get a clear clarity. The drain of the N-channel MOSFET, it is nothing but the N-channel MOSFET, no doubt. It is shorted to the gate. The drain is shorted to the gate only now. The drain of N-channel JFET is, N-channel MOSFET is shorted to the gate is given. You know very well. You know very well. Suppose you are given any MOSFET in this form. Any MOSFET is given. This point is nothing but the drain, you know very well. and this is said to be what now? Gate, no doubt. This is said to be gate only now. But in the question, drain and what now? Gate or shorted is given. Drain and gate shorted only now. Whenever drain and gate is shorted, this voltage equal to VDS is equal to what? VGS only now. These two voltages are same. We don't have this voltage, zero voltage. That means these two voltages will be same only now. But you can understand one point, you have to understand one more point also here now. If for the MOSFET drain and gate are directly shorted, you think it's so. At the time that MOSFET can act as can be in what mode of operation? It is in the region of the saturation only. The drain and gate is what not directly shorted, you think it's so. You no need to do any calculation now. You no need to what now? Identify the mode of operation of this MOSFET. It is in saturation only now, 100% only now. If you got any doubt, you can do the what now? Mathematical work only now. What work we have to do? VGS must be greater than the threshold voltage, and also it is given VDS must be greater than or equal to VGS minus VT. These two conditions are satisfying, means you can say MOSFET is in saturation region. But in this case, all these conditions, these two conditions no need to apply here now. Directly you can come to the conclusion only now. What? The MOSFET is in saturation. Reason is what? Means drain and gate are directly shorted. That is like you say. Now you can write the point here now like this now. MOSFET is in saturation mode. It is in saturation mode only. MOSFET is in saturation mode. Directly I can put it is in saturation mode only now. And also in the question, what data is given in the problem? Threshold voltage of the MOSFET is given here now. Threshold voltage is nothing but the VT. That is given as a 1.1 volt it is given. Drain current equal to here given ID1, I can put here now better now. ID1 is given 1.3 milliamperes. ID1 is 1.3 milliamperes. That much amount of the current is possible when VGS equal to 3 voltage only now. VGS1 I will put here now. VGS1 equal to here given 3 volts. VGS1 equal to 3 voltage, ID1 is nothing but the 1.3 milliamperes only. But in the question what is asking, when VGS equal to 5 voltage, that means VGS2 I can put here now. VGS2 equal to 5 volts. You find out the drain current. That means that current I will put ID2, I will put it is better than all. That value is required now. That value is required now. Every students know better. When the MOSFET is in saturation mode, the formula for the drain current is well known. Kn into VGS minus VT whole square. You know very well. That formula we can apply only now. But ID2, if you want to find, Kn value is same for even for the ID1 and ID2. They are nothing but the internal, by using the internal parameters of the MOSFET, Kn will be existing here now. Anyhow, that Kn value for the what now, ID1 and ID2 will be same only now. There's a, by using the data given in the first case, we can determine the Kn. Once the Kn value you are getting, you can determine the ID2 value only now. The point what I wish to say is, when the transistor is in saturation mode, the drain current is nothing but ID1, I can put directly Kn into VGS1 minus VT whole square. This formula directly I can apply in this particular problem. But by using ID1, VGS1 and VT, I can determine the Kn value. By using that Kn value, I can determine ID2 value here now. Fetching my point now. I say ID1 is given in the problem 1.3 milliamperes. I will put as it is 1.3 milli. 1.3 milli it is given. Kn value given. ID1 is given 1.3 milli. Kn is required. VGS1 is given as a 3 volts. Threshold voltage is given in the problem 1.1 volts. 1.1 volts. Now you can determine what is Kn value here. What is Kn you determine. That value I can get 1.3 into 10 power minus 3 by 3 minus 1.1 whole square. Use calculator and give Kn value. What Kn value is possible? Anybody? Anybody can give Kn value? Mostly it comes as a 0.36 milliamperes. 0.36 milliamperes per square volts. Square volts possible. 0.36 milliamperes per square volts mostly possible. Sir, why we are getting these Kn values are? By using this Kn only, I can determine ID2 only here now. I say, I want to get ID2 here now. ID2, I can get same Kn. This parameter will not be changed. Even if the gate to source voltage is changed. VGS2 minus VT whole square. This formula we can apply directly now. But every value we know, you can determine ID2 directly now. ID2 is calculated by Kn we got as a 0.36 milli. 0.36 milli 10 power minus 3. VGS2 is given here now 0.6 milli amperes per square volts. And also VGS2 is given here now 5 volts. This is given 5 volts. What about VT? Threshold voltage is given here now. What is the threshold voltage is given in the problem? VT is given 1.1 volts. 1.1 whole square. Use calculator. You will get ID2. ID2 comes as ID2 value is nothing but 5.475. 5.4756 milliamperes possible. 56 milliamperes possible. Such a way the calculation of ID2 is to be made only now. Understand my point now. Here don't arise the what no doubt here now. Sir, is it in a saturation mode or cutoff mode or otherwise what now? Is it in a linear mode? Otherwise triode mode. You will say triode mode, otherwise no. You will get a doubt only now. But the doubt is not acceptable. Why, sir? The drain and gate is shorted, directly given. So 100% this MOSFET is in saturation. That's why the formulas related to the saturation I applied in this problem only now. I will give the next question. You please try to tackle this now. Yes, this is the next question. You please start doing this question. I want to give some time. You please start doing this question. Take time and complete this question. Can you try this question? This question is also from the MOS capacitor. From the MOS capacitor, this problem I gave. Anybody? But what is given in the problem? The capacitance of the following MOS capacitor, when epsilon R1 equal to 4, epsilon R2 equal to 6, D equal to 5 mm, and area of the cross section 30 cm square is dash picofarads. Is asking to find the capacitance of the MOS capacitor. Capacitance of the MOS capacitor only now. Here the material 1, material 2, what now? Material 1, oxide 1, for material 2, oxide 2, p-type it is given. The distance between these 2 points is given d by 2 only now. How we can find this capacitance of the capacitor for the MOS capacitor only? I will do, please watch now. I will do this now. You can understand clearly. What is given data? We try to note down it first. Then it becomes very simple. The formula we can create here easily now. From that we can get answer easily now. What is given in this problem? Epsilon R1 is 4 epsilon R1 is given 4. Relative permittivity is given 4 here. No units for this. Epsilon R2 is 6. Epsilon R2 is nothing but 6, it is given in the problem. Epsilon R2 is given. And also D is given. We are using the D. Distance between these two is nothing but D by 2, it is given now. So D equal to 5 mm. D equal to 5 mm is given. 5 mm, but all are given in centimeters or meters, you watch it now. All are given cross-sectional areas, centimeters are given here now. And epsilon naught farads per meter. We can convert into the what now, centimeters, it is still good, I think now. Centimeters we can convert, it is still good only now. So centimeter is required means how we can convert 5 into 10 power minus 3. Meter, if you are converting into the centimeter, meter you are converting into the centimeter, you need to multiply by what? 10 square you can multiply now. 10 square you can multiply. Instead of 10 square you can write it. It comes in centimeter only now. So D can be taken 5 into 10 power minus 1 centimeter is possible. 5 into 10 power minus 1 centimeter is possible, D value. Understand now? That much value is possible now. But a 5 into 10 power minus 1 means still you can write 0.5 centimeters, no doubt. That we can put 0.5 centimeters, we got it now. Still given any more in the problem. Relative permittivities are given. Area of the cross section is given 30 cm square, 30. A is given 30 cm square, no doubt. 30 cm square it is given. And any more else it is given in the problem? Is asking capacitance of the following picofarads only required. Capacitance, C equivalent is required. Is asking to find C equivalent value, how much from this problem. But epsilon R1, epsilon R2, I said relative permittivity. So now, how we can form? First of all, the equivalent circuit we need to form. The equivalent circuit we need to form for the given diagram. Material 1 can have the what now capacitance of the capacitor, because these also having some dielectric capacitance of the capacitor. C1 is nothing but the capacitance of the capacitor for the first material 1. For material 2, capacitance of the capacitor is nothing but the C2 I want to take. But these two are in series only. Don't say both are connected in parallel, sir. You should not consider like that now. One is a dielectric, second dielectric. Whenever you got, those two must be taken in series only now. I will draw the diagram here now. You can understand clear now. I say this diagram is plotted like this. Two capacitors here existing because of the two different materials. One is a C1, second one is nothing but the C2 we can write now. But I want equivalent capacitor. C equivalent is required for this. That is required. From the basics only you can find when the two capacitors are in series, you know very well. C equivalent you can determine directly. C1, C2 by C1 plus C2 I can write clearly. Directly I can write now. What about that C1 and C2 sir? C1 equal to you know A epsilon. C1 is nothing but A epsilon. Epsilon naught into epsilon R1 by distance between the what? Distance it is given for the material 1. Distance D by 2 I can write now. By D by 2. D by 2 goes to numerator. For C2 I can write in the same way A into epsilon naught into epsilon R2 divided by distance. What distance is given? D by 2 is given. This also. I can write directly D by 2. This is D by 2 is possible. Divided by C1 plus C2. C1 plus C2 means I can write here now. C1 plus C2 same it comes now. C1 equal to what I know? 2A epsilon naught epsilon R1 by D1 here. D plus 2A epsilon naught epsilon R2 by D I can get here now. I would like to simplify. Without simplification I can't get directly now. Then I want C equivalent here. I want C equivalent now. But you try to simplify this now. Whenever the simplification LCM is a D, D means one D cancels, still one more D will come to down only now. If the 2 is taken common, 2 times you can cancel. 2 2's 4 means 4 by 2, 2 times it is cancelling. 2 times it is cancelling. A square is nothing but the area square. 1A is taken, 1A only will come here now. 2A. And also epsilon naught whole square. Denominator epsilon naught is taken, one epsilon naught will be cancelled. Still left one more epsilon naught. Yes, we got 2A epsilon naught, and also 1D goes to down, no doubt. Here I am getting epsilon R1 plus epsilon R2, I can write clearly now. By D is also possible here. By D, 1D comes, D square means 1D cancel here now. Here what I can get, 2A epsilon naught is cancelled here now, and still left epsilon R1 plus epsilon R2 only we are having here now. What we are having, this is a product only, numerator product only, sorry. Numerator we got the product value only. The numerator is the product value only. Epsilon R1 into epsilon R2, no doubt. R1 into epsilon R2, product these two only now. Epsilon R1 into epsilon R2 I can get. Divided by denominator I will get. Denominator I can get epsilon R1 plus epsilon R2 I can get only now. Now by using this formula you can find out the what now, C equivalent value. Anybody can substitute the values. All the values you try to substitute here now, you'll get answer. But a 2 into we know very well, area is nothing but 30 cm square. 30 cm square. 30 cm square I can write. All are in cm only. 30 cm square. And epsilon naught is nothing but 8.85 into 10 power minus 14 for farads per centimeter. Farads per meter is nothing but 10 power minus 12 it comes now. Meters to centimeters to convert. That's possible. Epsilon R1 into epsilon R2. Epsilon R1 is given 4. Epsilon R2 is nothing but 6 here now. The whole divided by D is nothing but 0.5 centimeters only. 0.5 centimeters here we got. Into epsilon R1 plus epsilon R2. Epsilon R1 is a 4, epsilon R2 is nothing but 6. Now you calculate what C equivalent you can get from this problem. What C equivalent you can get. Use calculator. Anybody can give answer for this question? Any student can give. Mostly it comes at 25.48. 25.48 picofarads possible. That much capacitance of the capacitor for this MOSFET you will get now. This way we can get now. It's not complicated, very simple question. Understand now. Yes, I want to go to the next question now. Follow this. Now you please try this question without my help. You please try this. But I want to give in your hand initially. You think yourself and try to give answer. You make an effort to get answer for this question. I wish to give some time. You take some time and try to do this question. Anybody? Anybody can solve this question? Just try to understand the concept which is there in this particular problem. Using that concept, you try to tackle now. Understand the methodology to do the question first of all. What is given? CV curve of step-graded PN junction is given in figure below. The C and V. C is the capacitance of the capacitor in microfarads it is given. Is asking to find the built-in voltage of the diode is dash volts. Built-in voltage means, you know, in the depletion region, it is going to form the voltage. That voltage is built-in voltage of the diode only now. Built-in voltage of the diode only now. Understand now? How we can find that built-in voltage? What way we can find? But in this problem, this is from the given data, you can get one idea. What idea you can get here now? How this is biased. This PN junction diode is biased with what? No, reverse biasing or forward biasing. You can understand from the given data only now. All the values are given negative values only now. All the values are given negative means PN junction diode is a reverse bias only now. When it is in reverse bias, I can get the capacitance of the capacitor. That means what the depletion region is going to be increased. Junction capacitance is going to form only now. By using the formula of junction capacitor, you are going to get the built-in voltage of the diode only here now. But you try to catch my point here that this point is not given, but this point is nothing but the zero voltage only. That point you have to remember now. Understand? Must be given mostly. This is a zero voltage only now. This voltage is zero voltage only. But using this data, you can tackle easily now. How we can tackle, sir? You please watch. I will do now. Clearly, I will do now. You will get the full concept of this question. The students know very well about junction capacitance. C I have taken here now. C proportional to when it is a reverse bias, C proportional to under root of VBI plus VR. There is this formula. Mostly C proportional to 1 by root of VBI plus VR is there now. You know very well. When the PN junction diode is a reverse bias, general formula is one. C equal to how much, sir? C equal to, if it is taken some proportionality constant, you are going to get, that is taken K by under root of VBI plus VR I have taken now. VR is nothing but the reverse voltage, reverse bias voltage for the PN junction diode. VBI is nothing but the built-in potential only now. VBI or V0, any symbols you can put it now. It's not a big matter now. But here the unknowns are, but the K is unknown here, VBI is unknown. These values are required now. How we can find this VBI? You please watch. The given curve you watch, CV curve is given here now. In the CV curve, I can note down when V equal to 0 voltage, what V this one? Reverse voltage only. Reverse bias voltage, all these parameters. When VR equal to 0 voltage, capacitance of the capacitor is nothing but the 1 microfarad. It is given in the problem. From the given table, I can write. When built-in voltage is nothing but, try to catch my point. VR is nothing but the 0 voltage. When VR equal to 0 voltage, in a problem it is given clearly. What is given? C is nothing but 1 microfarad it is given. C equal to 1 microfarad. I will put C equal to 1 microfarad is given. This is the data we can substitute in this particular equation only. C is nothing but 1 microfarad. Yes, I will use 1 microfarad. K by, I can write K by under root of VBI. VBI is nothing but, we need to calculate this built-in potential. VR is given 0 voltage only. This is 0 voltage only. Then finally I can get K by under root of VBI only. This I want to take it as equation number 1. Just I want to take that as an equation number 1 only now. But their unknowns are 2. K is unknown, root of, and also VBI also unknown only now. So to find out the 2 unknown values, we need to have the 2 equations only. So far we are getting the 1 equation. And second equation I can get from the one more parameter from the CV curve. One more parameter what I can put, they're given, when VR is nothing but reverse voltage is 0.6 voltage, given clearly. What capacitance of the capacitor is possible? That is 0.5 microfarads it is given. corresponding to minus 6 voltage, 0.5 it is given. Using that data, you try to form one more equation here now. I say, when VR equal to minus 6, I will put here now. VR equal to reverse voltage is nothing but minus 6 voltage here. Minus 6 voltage, it's given C equal to 0.5 microfarad. C equal to 0.5 microfarads it is given. Microfarads it is given. Now by using this data, I would like to form second equation. So when I substituted these values here, now C is nothing but 0.5 micro here given, K by here under root of VBI plus VR. VR is minus 6. I can put directly. VR is minus 6 only now. VR is given minus 6 only now. You put minus 6 or what's given now? VR is nothing but anyhow this is a minus 6 only because VBI minus VR is finally 6 voltage only possible. Because minus how it come now? VBI minus mostly VBI minus voltage, that voltage mostly minus or minus plus is possible now. That's why directly VR value directly can put 6 voltage only. You know. Catch my point. Catch my point. What I say, directly you can put 6 voltage. Followed or not mostly. The K value they will put built-in voltage minus reverse bias voltage. Minus 6 you are given. That means VBI minus of this minus plus only possible. That's why VR is taken magnitude 6 voltage only now. Plus 6 we can put directly. Plus 6 only now. Sir, why not taken minus R? Because general formula VBI minus voltage only now. That's supply voltage. That minus R, that minus only can give the plus only now. At the time you take the magnitude of VR is best only now. Anyhow, I am getting the what now? Second equation also here now. Now you can divide first equation by second equation. You will get the required value. I say I want to divide equation 1 by equation 2. Equation 1 divided by equation 2 I want to take. If I divided, what I can get here now? I am getting 10 power minus 6 by 0.5. Sorry, 10 power minus 6. 10 power minus 6, 10 power minus 6 cancel now. 1 by 0.5 possible. 1 by 0.5 here. 1 by 0.5. That equal to what I can get? That equal to this by this. K by root of VBI. K by root of VBI I can put. Divided by K by what is given? K by VBI plus 6. VBI plus 6. VBI plus 6 I am getting now. VBI plus 6 only. Yes, that is the value we are getting. Now we can simplify. 1 by 0.5 is nothing but 0.2. What now? It comes as a 10 by 5. 2 is possible here. K cancel here now. Root of VBI plus 6 divided by root VBI is possible. Root VBI is possible. That much value we are getting now. That is the equation we are getting now. But my aim is to find the VBI only now. Squaring on both sides. Whenever the squaring is made, 2 square is a 4 here. Because the squaring, this is cancelled here now. VBI plus 6 divided by VBI I can get now. Now cross multiply 4 VBI here, that equal to VBI plus 6 is possible. VBI plus 6. 4 VBI minus VBI is nothing but 3 VBI I can get here now. That equal to 6 is possible. Finally VBI is nothing but 6 by 3 is nothing but 2 voltage possible. VBI equal to 2 voltage we are getting. That is the built-in potential only. Yes, exactly we are getting 2 voltage now. This is the answer. Why this VBI is increased? 2 voltage means more only now. That voltage why we are getting means when the built-in, when it is connected by the reverse biasing now, what is going to happen now? Depletion region is going to increase, then built-in potential also here increase only you can say. This way we can tag it now. The students what they have to understand, by using this particular By using this particular diagram, we need to create the equations 1 and 2. Once you are getting the equation 1 and 2, you can get the required VBA only. I think you followed. Now, I want to give one more question in your hand now. I want to give one more question. Yes, you tackle this question now. You please try this question without my help. Anybody can do this question? Anybody can do this question? But I want solution for this question. Your work is required. Anybody can do? But you take some time and try to get answer. Output characteristics of N-channel MOSFET is given below. All of these questions are MOSFET only now. I said from the beginning I am informing you. The MOSFET and also the semiconductor given much importance in EDC. In EDC, these two chapters are given much importance for gate only now. That is why I gave the more number of the questions from the MOSFET and what semiconductors only now. And certain number of the problems only I gave it from the PN junction diode and BCD. Understand now? Anyhow, you please start doing this question. Output characteristics of N-channel MOSFET is given below. This is the output characteristics of MOSFET. Because VDS versus ID, if it is given, that becomes output characteristics only. Drain current versus drain to source voltage. Channel length modulation constant is dash per voltage up to 3 decimal places. Is asking to find the channel length modulation only. Modulation constant. Anybody can do this question? Channel length modulation constant is denoted by symbol lambda. You need to calculate lambda value only now. What is the channel length modulation? Anybody having any idea? Any student having idea about channel length modulation in the MOSFET? Channel length modulation means what now? But mostly once output characteristics, whenever drain current versus drain to source voltage, if you plot it, the shape of the curve generally comes like this. Linear, it goes to some extent, then after it reaches to saturation. Saturation means even if you are changing the drain to source voltage, drain current will not be changed. That's going to remain constant only now. That's going to remain constant. That's why this is going to remain constant in this particular place from this point onwards. If it comes exactly straight line from this point to ending, you think it's up to some extent, there is a saturation level. There's a constant value. In that case, channel length modulation constant is 0 only. When channel length modulation constant is neglected, you will draw directly one straight line like that only now. That means change of drain current is not possible even if you are changing the drain to source voltage. Channel length modulation is considered means what happened now? Practically, you cannot get such a way the figure. Output characteristic curve is not available such a way. That means a VDS versus ID diagram, if you plotted here, practically it goes like this. Slightly it is going, some extent it goes, slight slope will come here now. Not much variation, slight variation only it comes, slight variation. It must go this side, but it is going like this only now. It's going like this only. Slight variation. Channel length modulation available due to change of this position only. Channel length modulation constant. You'll get here only now. Lambda. Variation done. That means slight variation in the what now? That means the VDS is changing, means ID also changing here now. The saturation. That's why here consider channel length modulation only now here now. This is not considered now. But in the diagram you watch it here now, slight slope is existing here now. From this point onwards, I say, from this point, it is not being constant. Slight variation we are finding. Exactly it has to go like this in the saturation. Slide down. But how we can find that lambda value? You know, drain current formula in terms of the channel length modulation is more important now. That formula you must take. Drain current in terms of channel length modulation is required. By using that formula only, lambda value is determined only now. How we can get? Sir, no data is given in this particular problem, sir. Yes, from the diagram, the required data you must collect only now. Then you must calculate lambda value. I will calculate lambda value, please watch. But in this problem, drain current is calculated by, I will put in the next page, I will do best. The drain current you can calculate. Solution I am putting here now. Drain current in terms of channel length modulation constant. Channel length modulation constant. Modulation constant is how that formula is to be taken. That's more important. That is taken in this way. ID equal to, they will take like this now. ID equal to half into mu n into COX into W by L into VGS minus VT, VGS minus VT whole square into 1 plus lambda into VDS. This formula is generally used. You know very well, when the MOSFET is in saturation, generally what formula we are going to use? ID equal to 1 by 2 into mu n into COX into W by L VGS minus VT whole square. There, this term will not be considered. This term is not considered. That means that when the lambda is taken 0, that means we are neglecting channel length modulation. In that case, this formula. When channel length modulation constant is considered, this formula you need to use only now. But as per the given figure, channel length modulation constant is needed only now. Anyhow, that only is asked now. There we can substitute the what now? The data we can note down here now. What data you can get from this particular diagram here now? When VDS is maintained 3 voltage, catch my point. When VDS is maintained, when VDS equal to what now 3 voltage, current is nothing but 1 milliampere. First point. When VDS equal to 5 voltage, catch my point. Corresponding to 5 voltage, we are getting drain current is nothing but 1.2 milliamperes. By using this particular data, you can determine the needed value of lambda directly now. I say when VDS equal to 3 volts, I will put when VDS equal to 3 volts. When drain to source voltage is nothing but 3 voltage, drain current is given in the problem. What drain current is given? 1 milliampere. It's given 1 milliampere. 1 milliampere it is given. This is VDS1, I will put best. This is ID1, I will put. That's best. In the same way, when VDS2 is nothing but, what voltage is given? VDS2 is a 5 voltage. VDS2 is nothing but a 5 voltage. Drain current is given in the problem. What drain current is given in this problem? 1.2 milliamperes. 1.2 milliamperes only given. 1.2 milliamperes. Using this data, we can get only now. But here, catch my point here now. But here the ID1 and ID2, I want to know down here now. I can form the equations like this now. ID1 by ID2, I have taken for example. I want to know down ID1 by ID2. ID1 by ID2 means ID1 I can write half into mu n COX, these terms are constant internal parameters, into W by L, into VGS becomes VGS1 minus, VGS1 minus VT is possible here now. VGS1 minus VT is possible here now. Yes, you can write now. VGS minus gate to source the same only, VGS minus VT whole square into 1 plus lambda into VDS1 I will put. VDS1 I will put. In that case, gate to source voltage and threshold voltage will not be changing. Those values are going to remain constant only now. So change is VDS1 changes, ID1 changes. Divide by half into ID2 is equal to half into mu n into COX into W by L, W by L only now. Into VGS minus VT square into 1 plus, this is a lambda I have taken now, 1 plus lambda into VDS2 I can put now. VDS2 I can put now. Then you can cancel these terms. These terms are cancelled. This and this cancel. This and this cancel. This and this cancel. This and this cancel. Finally, I can get formula like this. ID1 by ID2 is nothing but 1 plus lambda into VDS1 divided by 1 plus lambda into VDS2 is possible. Such a way equation is formed. By using this equation, you can determine the required value. What is ID1? ID1 is given 1 milliampere. ID1 is given 1 milliampere. 1 milli cancel here now. 1 milliampere by ID2 1.2. 1.2 this is 1.2. This is equal to 1 plus lambda into VDS1. VDS1 3 volts. This is given 3. Divide by 1 plus lambda into VDS2. What about VDS2? VDS2 is given 5 volts. 5 volts. Now you calculate this, just cross multiply and find what is lambda value. 1 plus 5 lambda, that equal to 1.2 into 1 plus 3 lambda, you can get here now. Just take cross multiply. They were required lambda, 1 plus 5 lambda, 1.2 into 1, 1.2 only. This is a 3.6 lambda is possible. 3.6 lambda. 5 lambda minus 3.6, 5 lambda minus 3.6 lambda equal to 1.2 minus 1 is possible. Finally, 5 lambda minus 3.6, 3.6, 4, 1.4 lambda. That equal to, here I will get 0.2, 1.4. So lambda you calculate directly. What lambda value you can get? Lambda value 0.2 by 1.4. 0.2 by 1.4 is nothing but it comes as 0.1428. 1428 is possible. Units are per volt is possible. Per volt only possible. Per volt is possible. This is answer. This is the solution for this question. That means when the effect of the channel length modulation is existing, even if the drain to source voltage you are changing, drain current is going to remain constant. When there is no effect of the channel length modulation, I said no. If there is an effect of channel length modulation, change of drain current is possible. With a change of drain to source voltage. That point only specified in this problem. Yes, you try for one more question. I will give in your hand. Please start doing this question. Start doing this question. Anybody can get answer for this question? I want solution for this question. I think any student can give answer for this very easy. Start doing this question. I would like to know how many number of students can do this problem. I would like to know. Any student can do this question? What is given in this problem? In a transistor, base transport factor is 0.988. Base transport factor is given. And emitter injection efficiency is 0.995. 0.995 is given. Reverse saturation current of collector to base current is 2 microamperes and base current is 0.05 milliamperes. Then collector current of the transistor is dash milliamperes. The finally is asking to find, what is asking to find? Is asking to find collector current of the transistor. IC value is required. How to find out IC value? That is required in this problem. First of all, you try to note down the data given here. Try to note down the data and substitute relevant formula needed here now. Understand now? That means I can do like this now. This problem I will do, please watch. If a transistor base transport factor is 0.998, base transport factor. The base transport factor is denoted by a symbol B asterisk. B asterisk. Beta asterisk they will put. Some people will put beta asterisk, some people put alpha suffix T also they will put. Any one of the letter you can put, it doesn't matter now. I have taken beta asterisk. Base transport factor is 0.998. 998. And second one, an emitter injection efficiency is 0.995. And what is given? Emitter injection efficiency is 0.995 is given. But already you have seen in the problem emitter injection efficiency that is denoted by symbol gamma asterisk only now. How to find out the gamma asterisk if internal parameters are given? What are the internal parameters? I said already. What are concentration values in the N type and in the emitter and base and collector, and also length of the what now? Emitter, base and collectors are given, and also lengths are given, and also concentration is given here now, and also diffusion coefficients are given. Means how to find out the gamma asterisk? I explained before. But in this case, directly given emitter injection efficiency is nothing but gamma asterisk, you know very well. Its value is given as a 0.995 is given in the problem. Reverse saturation current of the collector base current is, reverse saturation current of the collector base current means ICBO. In certain textbooks they will write ICO also. ICBO or ICO. Both are approximately equal. That's you can write ICBO, you can put. Not required means ICO also acceptable, no problem. That is nothing but 2 microamperes. The reverse saturation current also we can call this now. This reverse saturation current, why it is generated? Whenever base to collector junction is broken down, base and collector junction is there now. In case number of covalent bonds are broken down in between emitter and base due to the temperature, what is going to happen now? Multiple number of electrons are going to generate only now. The generated electrons are going to create their reverse saturation current only now. That means the bonds, whenever it is broken down in between the collector and base, at the time it is going to generate certain number of electrons. The flow of these electrons can establish a current. That current is nothing but the ICBO or ICO or leakage current also you can put it now. That way we can write now. Anyhow, that leakage current is given in the problem, you know. That is 2 microamperes. It is given clearly. Clearly it is given. And base current is given, IB is given in the problem. What base current is given? 0.05. 0.05 milliamperes of current is given. Is asking to find the collector current now. IC is required only now. But you should understand one more point in this case now. IC equal to beta into IB, sir. Just I will apply beta into IB, I will get the answer, sir. That is not acceptable now. That is not acceptable at any cost. Sir, why not acceptable that formula? IC equal to beta into IB, I can apply if it is not given or if it is neglected leakage current only now. But the leakage current is given in the problem. When the leakage current is given, the collector current is required with the relation of the ICBO only now. What formula you can apply? The collector current is calculated by beta into IB plus 1 plus beta times of ICBO. The formula is generally used. IC with the relation of ICBO and IB. That formula is used. Now just substitute the values and get answer. Well, the students may ask the question, sir, their beta is not given in the problem, sir. So we need to calculate. Beta and beta asterisks are different only now. Beta is nothing but the current gain of the transistor. Current gain of the transistor. That means the common emitter configuration you might have studied. Current gain of the transistor is a beta value. Its value is between 20 to 500 already. I explained in many lectures in the YouTube. It is given here now. It's given before now. But anyhow, beta value lies in between 20 and 500 only now. Within that range only possible here now. But this value, whatever we are getting, we can see now. How to get this beta value? That beta, but a beta asterisk and gamma asterisk is given. You can determine alpha value at first. Once alpha value, you know, beta value you can calculate very easily now. So beta equal to alpha by 1 minus alpha, you know very well. I say the alpha is calculated by beta asterisk into gamma asterisk. That means base transportation factor into emitter injection efficiency. These two products is nothing but the alpha. Alpha is nothing but the current gain of the transistor. In the common base configuration, alpha we are going to use only now. There I will get alpha value. What is alpha value? Anybody? Anybody can give? Beta asterisk is nothing but 0.998, this value. Gamma asterisk is nothing but 0.995. When the product of these two are made, I will get alpha. That alpha is nothing but, that alpha is 0.993. 0.993 is possible. 0.993. Yes, by using this alpha value, you can determine beta value. So how to get beta? Beta is calculated by relation between alpha and beta, you know. Beta equal to alpha by 1 minus alpha. We are going to use generally. Alpha is nothing but 0.993 divided by 1 minus 0.993. I can use calculator. Its value comes as 142 approximately. 142 approximately comes. Approximately 142 you are going to get. So by using this beta, you can determine IC value now. Substitute all the values here now. I want to substitute here now. IC equal to, you know very well. Beta into IB. Beta is a 142. IB is nothing but 0.05 milli 10 power minus 3 I can write. Plus 1 plus beta. 142 plus 1, 143 comes here now. 143 into ICBO. ICBO is nothing but 2 microamperes only. 2 into minus 2 into 10 power minus 6. Use calculator. You'll get answer now. 2 micro, What is the value? Anybody? What is IC value? IC value is 7.386. 7.386. 7.386 milliamperes of current you will get. That much value is possible. Such a way you can determine. Did you understand? Anybody having any doubts regarding this question? If any student having any doubt, they can arise their doubts. I am ready to clarify. Any student? Yes, I wish to give one more question in your hand. You please tackle this question. Yes. This is the question, you please try. You please complete this question. You take time and complete. I want to give some time. Start doing this question. Start doing this question. Anybody can do this question? Say 10 power minus 8 mostly comes, not 10 power. 10 power minus 8 it comes. 10 power minus 8 I said. Yes, you can try. Anybody? Yes, I will start now. In a MOS capacitor, the gate voltage exceeds threshold voltage by 1 voltage. Gate voltage exceeds the threshold voltage. What is the meaning of this? You cannot take that 1 voltage is nothing but the gate voltage, not allowed. It is exceeds the threshold voltage. That means VGS minus VT, if it is taken, that difference is what? VG minus what? No, VT. VG minus VT is given 1 voltage only. Or VGS minus VT is nothing but 1 voltage is specified in the problem. Understand? That point very important. VGS minus VT is given here now, 1 voltage. And the oxide thickness is 25 nanometers. T-ox is given, oxide thickness only now. Then the inverse charge density of the channel is inverse charge density Q dash. Generally they will put now. Q dash equal to how much is asking. Relative permittivity is given 3.9 and epsilon naught is given something. You calculate inversion charge density of channel. Anybody? I will do these words. I want to do this question. It's a very simple question. In this particular problem, given threshold voltage is, but no, the gate voltage exceeds specified. Gate voltage exceeds, clearly given. Gate voltage exceeds the threshold voltage by 1 voltage is given. That point indicates what I said. You must take VGS minus VT equal to what? Gate to source voltage minus threshold voltage is 1 voltage. It is exceeding only now. VGS equal to VG we can take now. When the VS is what now? When the source is grounded, VGS equal to VG only positive. So VG minus VT or VGS minus VT equal to 1 voltage only. If the oxide thickness is given, T-ox is given here 25 nanometers. 25 nanometers is given here. Answer is required coulombs per cm square, nanometers. Nano equal to, we know, 25 into 10 power, what we can put now? -9. Meters to convert into centimeters, 10 square is possible. And finally, 25 into 10 power -7 centimeters possible. 25 into 10 power -7 is possible. For 25 nano means 10 power -9. Meters to centimeter, 10 square I have taken. On simplification, I got this. T ox, this value. This is nothing but T ox, you know very well. But after that, what more else it is given? The inversion charge density of the channel is, there's a Q dash, is asking to find. Q dash or Q, we know very well. And the relative permittivity is given here. Epsilon R is given 3.9, no doubt. And epsilon naught farads per centimeter, 8.85 into 10 power -14 farads per centimeter is given in a problem. This is the data is given now. So how we can find the Q dash? We know very well. The charge density of the channel Q equal to, what you can use now? C into V. Generally, you know, capacitance of the capacitor equal to charge by voltage. Charge equal to how much, sir? C into V. You will write now, C into V. Same concept. Q bar, I want. Q dash, I want. So we can write clearly C ox, capacitance of the capacitor by the oxide coating only now. By oxide, because oxide onwards only is required now. Because the thickness is for the oxide only given now. Thickness for the oxide is given. Capacitance of the capacitor also required for the oxide only now. Understand now. C ox into, we can use VGS minus VT. The capacitance of the capacitor into voltage is nothing but the charge, you are saying now. But the charge generally you will get in coulombs only. Coulombs per cm square required. Coulombs per cm square is given. Coulombs per cm square means COX is required farads per cm square only. Per area one, you know. COX is nothing but farads per cm square only we want, you know. Understand my point now. Anyhow, COX is nothing but epsilon naught by oxide thickness. Don't multiply here by area. Area not required. Why you are not putting area? I want COX farads per cm square. I want. Per cm square means area can be removed. Into VGS minus, we know very well. VGS minus VT you can write directly. Then I can determine Q dash. Epsilon naught is given 8.85 into 10 power -14 is given here now. Relative permittivity is given in the problem, 3.9. 3.9 is given. Divide by, but TOX, 25 nanometers. There is a TOX given, 25 into 10 power -7 I got. 25 into 10 power -7 I got. That into VGS minus VT is nothing but 1 volt directly you can write now. That is 1 volt. Use calculator and give its value. If you are using the calculator, it comes as 13.8 into 10 power -8. 10 power -8 coulombs per cm square mostly possible. Coulombs per cm square. That much value is possible from this problem. That way we get that. The no student is here responding. If you are responding, subject is going to increase only now. Understand? Anyhow, this way we can tackle this question. Yes, I want to give one more question in your hand. You please try this question. You try to tackle this question. Yes, this is one more question. Can you complete this question without my help? Will you get answer for this question? The last problem, if you followed, you can do this question without my help. Without my help, you can complete this question. Anybody? If you followed last question, you can do this question very easily now. It's not tough. Yes, I will do here now. What is given here now? An ideal mass capacitor P-type semiconductor is shown in the figure. The mass capacitor is under strong inversion. Under strong inversion is given. The mass capacitor is under strong inversion with Vg equal to 2 volts. Gate voltage is given 2 volts. The corresponding inversion charge density Qin is, I have taken Qin dash before. In this problem, Qin only given. Inversion charge is 2.2 microcoulombs per cm square. Assume oxide capacitance per unit area as COX equal to 1.7 microfarads per cm square. For Vg equal to 4 volts, the value of Qin is dash microcoulombs per cm square, rounded off to 1 decimal place. That's given, and also given diagram. The diagram is nothing but it is a MOSFET, it is a metal piece, there is an oxide, it is a semiconductor. Gate is connected with a potential, and this is what now? This is connected to the ground only. Semiconductor is turner is connected to ground only. Yes, start doing this question. Can I do? Anybody can do this? Yes, I will do here now, you can understand. An ideal mass capacitor is shown in the figure. The mass capacitor is under strong inversion. Gate potential is given here now. Gate potential is given. Vg1 I will put. That is given as a 2 volts. Vg1 is given 2 voltage. The corresponding inversion charge density is, that means Q in. Q1 is given. Right, Q in is a Q1 I have taken now. Q1 of inversion charge to specify. There's a 2.2 microcoulombs per cm square is given in the problem. Microcoulombs per cm square given. Assume oxide capacitance per unit area as COX is given here now. COX is given as 1.7 microfarads per cm square. Farads per cm square means this is a capacitance of the capacitor per unit area given here now directly, per unit area. Vg equal to 4 voltage. Vg2 is given 4 voltage. Is asking to find the Qin. Qin means second Q2 inversion. I want that equal to how much? That is the question is required. How you can find this value? But in this problem, you try to understand, is it given threshold voltage or not? In the problem, you check it. We don't find any threshold voltage in this problem. Threshold voltage is not given. Initially, we need to calculate threshold voltage. That means by using the Q1, I can determine threshold voltage. If I get threshold voltage, I can determine same threshold voltage is maintained, even the gate potential is changed. Then you can determine Q2 also again. And I gave already formula. Q1 equal to, I gave it Q1 for the inversion charge, I gave it already. What I gave it? C aux into VGS minus VT I gave already. Already I gave it. That VGS equal to VG only now. Source will be grounded only now, we had assumed. VG minus VS. VS is to be taken 0 only. Source is connected to the ground only. Then I can take VGS equal to VG1. There is a 3. Otherwise directly can write this is 1. VGS1. I can put directly. Okay, this is a 1, we can put Y. Then I can write Q1 inversion is nothing but Q1 inversion is given 2.2 micro. 2.2 micro is given. 2.2 micro is given. Coulombs per cm square. COX is given 1.7 micro. 10 power minus 6. VGS1 equal to VG1 only. Gate potential only possible. That is to be taken 2 minus VT. Use calculator, you will get threshold voltage VT only. That voltage comes as, that value will be, you are going to get threshold voltage like this now. 0.706 possible. 0.706 volts you will get now. 0.706 volts possible. But in the next case, when VG2 equal to 4 voltage, you find out the Q2 inverse is asking, inversion charge is asking to find one now. So I wish to find what is Q2 now. The Q2 inversion I want. Q2 inversion is taken, COX will not be changed. Same only now. To VGS2 minus VT only possible. I can write Q2 inversion I want. Q2 inversion is required. That equal to COX is nothing but 1.7 micro. 1.7 micro I got. VGS2 equal to VG2 only here now. That is to be taken 4 minus VT is nothing but 0.706. If you are using the calculator, you will get Q2 only now. The Q2 value is nothing but 5.6 microcoulombs. 5.6 microcoulombs per cm square is possible. Per cm square is possible. This is the solution for this question only now. That way we can track it. But this model is just like a last problem only. In the last problem, same formula we applied instead now. This way we can calculate it. I hope you followed. But I want to give one more question in your hand. Please try this. Yes, you start doing this question. It's a very simple question. Just one theoretical question is given now. Anybody can give answer? I'll see how many students can give answer for this. Sometimes asking in the gates such type of questions, theoretical questions also. I would like to know what answer you'll get. Start doing this question. Anybody? Any student can give which option is correct in this particular problem. Which option is right in this particular problem? That's my question. Please try to give answer for this question. In a P plus N junction diode under reverse bias, the magnitude of electric field is maximum. Try to understand. It is a PN junction diode problem only now. P plus N. P plus indicates what? The doping is made more in P type only now. N type is less doping only made. It is under reverse bias is given here now. The magnitude of electric field is maximum at option A. The edge of the depletion region on the P side. Option B. The edge of the depletion region on the N side. C. The P plus N junction. D. The center of the depletion region on the N side. Which is right? I explained in the last class. In the last class, I explained one diagram also I have drawn clearly. Suppose you selected here P-type and N-type semiconductor. Try to understand this point. One side we got P plus, the other side you got the N-type only. More doping this side. But on which side you are having the more doping, there you can find the depletion region somewhat less. Less depletion region possible. Wherever the less concentration you got, there you can find the more depletion layer. Such a way it creates depletion region in PN junction diode. In case this it is given only P, this is given N. Both are less doped only now. Both are less doped means this side and this side depletion layer will be same. Even the P-type semiconductor, even the N-type semiconductor, you will find same width of what? Depletion region possible on both sides. But here the difference of the concentration is existing. That is why depletion region will be changing only, we can say here now. Suppose I want to draw the profile, electric field intensity profile I want to draw. Electric field intensity profile, if you want to draw, you need to draw the what now? The charge density profile also more important now. The last class I explained, last session I explained. This is nothing but the rho V, volume charge density, I said. Volume charge density versus distance x only now. P plus can have the what now? This side electrons will move from N type to P type, thereby creating the holes over here. Then I can say this side is nothing but the point I can put like this now. This point is nothing but XP. You can put minus XP, you are going to get this side. This is negative charges. Negative means it comes negative side. And this side I got the positive. Positive means I will get like this now. Up to this extent I can get. On watching these diagrams, the students may get one is a big size, one small size, correct one. But the area if it is taken, it comes same only. This area will come same. Diagram may be plotted somewhat higher and lower. Finally, this area will come equal now. This is the volume charge density. I said in the last class, rho V by epsilon, integral rho V by V is nothing but you will get the electric field intensity. Electric field intensity I can get when rho V by epsilon is made with integration only. That means when the negative you got means what happens now here now, the electric field intensity will go this side. Negative side it is going to move. Then after positively it is going to move this side. It goes to this side. Where maximum electric field intensity is going to develop here now, this is the maximum electric field intensity possible. At this point only we can get maximum electric field intensity. Where we are getting maximum electric field intensity on the PN junction. On this PN junction we are getting the maximum electric field intensity. That is why we can write clearly. What I can write clearly? I can write in a P plus N junction diode under reverse bias, the magnitude of the electric field is maximum at the P plus N junction. Option C is correct only, we can say. This option is correct. Option C is correct, I can say. Such a way we can tackle this question. I hope you follow. Yes, I will go to next question now. You please try this question. but I want to wait again for some time to tackle this question. Anybody can do this question? Any student? If BJT is biased in forward active mode means it is an active region only now. Assume VBE equal to 0.7 volts. Base to emitter voltage is given 0.7 volts. KT by Q is nothing but the thermal equivalent of voltage. KT by Q is to be taken as a VT. VT is nothing but the thermal equivalent of the voltage, that is given 25 millivolts. And reverse saturation current IS is given 10 power minus 13 amperes. The transconductance of BJT in milliamperes per volts is asking to find the transconductance. Transconductance is denoted by symbol GM. GM equal to, how you will determine? IC by thermal equivalent of voltage. IC by VT will know. IC we need to calculate by using the given data. Start doing this question now. I explained what way to tackle this question. Easily you can tackle this question. It's not going to be difficult for the students, I hope. Please start doing this question. But I will do here now, please watch. But I wish to do this question. If BJT is biased in forward active mode, base to emitter voltage is given. Base to emitter voltage is given 0.7 volts. That's given. We know very well KT by Q is nothing but a thermal equivalent of voltage. Thermal equivalent of voltage can be written KT by Q also. That can be taken 25 millivolts. 25 millivolts I can put. And reverse saturation current IS is given. I0 or IS acceptable. IS or I0 is allowed. It's a 10 power minus 13 amperes it is given. The transconductance of BJT how much? He is asking to find the GM equal to how much? This is the given question. Anybody can tackle this question? Just now I said that transconductance is calculated by IC by what I said, VT. VT means thermal equivalent of voltage only. But their unknown is a IC value. If you are getting IC value, you can determine the transconductance only here. But how to find this IC, you please watch. IC is calculated by IS into IS or I0 into e power VBE by thermal equivalent of voltage minus 1 we can write. VBE by VT. Generally they are going to use IS into e power VBE by eta into VT it comes generally. For BJT, eta value is taken 1 always. It's a fixed value only. No need to use eta here now. Directly you can write e power VBE minus VT by minus 1. Now try to understand. VBE is nothing but the positive value. Base to emitter voltage is a positive value. Thermal equivalent of voltage is 25 milli only. 25 into 10 power minus 3. It becomes 10 power minus 3. 10 power minus 3 when goes to numerator, it becomes a somewhat bigger value. Positive value of big number it comes. VBE by VT is a positive value, somewhat big only now. E power positive value of large can give the larger value. E power positive value will give larger value as compared to 1. As compared to 1. At the time, this value is very, very large, 1 is a very, very small. So, IC is approximately equal to, you can write IS into e power VBE by VT. It is acceptable. It is acceptable. VBE by VT you can write now. But IC I can calculate by substituting the values. IC is nothing but IS. IS is given here 10 power minus 13. E power VBE base to emitter voltage, what is given? 0.7 given here. 0.7 divided by thermal equivalent of voltage VT. VT is nothing but 25 millivolts. 25 millivolts it is given. Then you will get IC here directly. IC value is nothing but 0.144 it comes. 0.144. 0.144 milliamperes. 0.144 milliamperes of current is possible. That much IC possible now. If you got IC, you can determine transconductance GM here. GM is nothing but IC by VT. IC is nothing but 0.144 milli 10 power minus 3 divided by VT. Thermal equivalent of voltage is given 25 milli. 25 into 10 power minus 3. And finally GM you will get GM equal to, you are going to get, if you are using the calculator, 5.76 milliamperes per volts possible. Milliampere, 5.76 milliamperes per volts possible. That is the transconductance value. Follow this, such a way you can determine transconductance value from the given problem. Understand? Anybody having any doubts regarding this problem? Any student having any doubt regarding this problem? Yes, you can try one more question I will give now. One more problem I want to give. Yes, you start doing this question. Yesterday, last problem I gave this only now. Yesterday part 1 electronic devices and circuits, same problem I gave it. Just that formula I derived, just I gave it, directly I gave it now. Now systematically we can do now. This problem I didn't give any options only now. Mostly he has to give the minimum conductivity for the silicon at 300 Kelvin is dash he has to give. But I gave it calculate only now. So without giving the options only now. Can you calculate minimum conductivity, sigma minimum? You start doing this question initially. Start doing this question. You can try initially this question. This is the given problem. Will you complete this question without my help? How to tackle this question? Calculate the minimum conductivity. Is asking to find the minimum conductivity, sigma minimum, for silicon at 300 Kelvin. At 300 Kelvin we want. Given that mu n is given at 300 Kelvin, 1350 cm square per volt second. Mobility of holes given 495 cm square per volt second. And intrinsic concentration given 1.5 into 10 power 10 per cm cube. Charge Q is given 1.6 into 10 power minus 19. How we can find the minimum conductivity? We know very well minimum conductivity, if you want to get, you can use this formula directly. Minimum conductivity, if you want to get. But a conductivity due to electrons, N into Qn, Q into mu N, P into Q into mu P. First this is a conductivity, sigma only we can use otherwise. I'm using conductivity. I want to denote sigma. Conductivity equal to this formula. Thereby required n value and p value. N and p values are required at minimum conductivity. Once you are getting the n and p values at minimum conductivity, then you can write sigma minimum, I will write. Then a formula we can create and we can substitute every one of the value here. How we can get n and p? You must get sigma in terms of n or in terms of the p. In terms of n or in terms of p to get concentration of electrons or concentration of the holes. If both are existing, concentration of electrons and concentration of the holes are two are existing means directly you cannot get it now. So what I wish to say, by using the mass action law, you must remove any one of the term here now. The P in terms of N you convert, N in terms of P1 now. Why mass action law is used generally in the electronic devices and circuits? For the sake of finding the minority carriers in the material only now. Minority carriers existing in the semiconducting material only now. But anyhow here the P value I can get by using the mass action law. But we know N into P equal to Ni square is the mass action law. It is the mass action law. This is the mass action law I can put. But from this I wish to get what is P. P is nothing but Ni square by N. I can write directly. Ni square by N. That P I would like to substitute in this particular equation. I can write conductivity is sigma equal to N into Q into mu N plus P is nothing but Ni square by N into Q into mu P I can write. I am trying my level best to get the conductivity. Minimum conductivity I want to create. Once you are getting the minimum conductivity formula, you can substitute the values only here now. That's why here I wish to find the n value according to the maximum and minimum. Whether it is a maximum or a minimum, it doesn't matter now. Derivative of this sigma with respect to n is equal to 0, we can put directly. Initially, I would like to differentiate according to maximum minimum condition. That condition if you want to apply, differentiate with respect to n? D sigma by dn. N derivative 1 q into mu n I can write here. 1 by n is a variable. 1 by n differentiation minus 1 by n square into ni square into q into mu p I can write. Ni square into q into mu p. But we know according to the maximum or minimum, no problem. According to the maximum or minimum, d sigma by dn must be equated to 0 for maximum or minimum. For maximum or minimum, you will do that only now. For maximum, minimum only now. Minimum. Otherwise, anyhow, minimum condition only we are using now. Directly you can put otherwise. According to for minimum only now, we can put y. According to maximum minimum or according to minimum, I am saying now. If it is equated to 0, what I can get q into mu n plus minus 1 by n square into ni square into q into mu p, you can write directly. This must be equated to 0. If it is equated to 0, I can cancel q and q here. I can cancel now. Then I want to find mu n equal to what I am getting here now. Mu n equal to, I can get mu n equal to, I can get, what I can get? 1 by n square. 1 by n square into, what I can get? 1 by n square into ni square into mu p. Ni square into mu p I can get here now. Ni square into mu p I get. My aim is to find the n. N square is nothing but ni square by mu n into mu p only I can get here. Finally, what is n? If I ask, you will say ni into under root of mu p by mu n I can get. So according to the minimum condition, I am getting n equal to ni into root of mu p by mu n. Similarly, we need to find out the concentration of holes also. Once we got these two values, I can substitute in the conductivity now. We got already here now, what we got? Conductivity equal to n into q into mu n I gave, plus p into q into mu p already given. I wish to find the p. If you want to get the p, you must eliminate this n. Eliminate means directly you should not remove. N, I want to convert in terms of p only now. If I got in terms of the p, I can determine by applying the maximum and minimum condition only now. I say according to the mass action law, I can say n equal to ni square by p, you know very well. According to the mass action law, I got this term here like now. So conductivity is nothing but n is nothing but ni square by p into q into mu n plus p into q into mu p. I can write here. But according to the maximum and minimum, you can differentiate with respect to what? P here now. D sigma by p I want to take. 1 by p differentiation is nothing but minus 1 by p square I can write into ni square here into q into mu n I can write, plus derivative of this p is a 1. I will get the q into mu p. Q into mu p I can get now. Q into mu p. And the derivative of this is equal to 0 as per maximum and minimum. You know very well. Thereby cancel this q directly. If I cancel, what I can get? Mu p is nothing but mu p equal to I will get ni square into mu n by p square I will get here now by p square I am getting here now. Mu p I am getting now. Because I want the p only now, is it not? But a p is nothing but concentration of holes equal to ni into under root of mu n by mu p. Yes, we got concentration of electrons and concentration of holes also we are getting. By using these two concentration, I can get minimum conductivity. By using these two concentration, how to get it now? You please watch. But I wish to find the minimum conductivity here. Minimum conductivity, I can write n into q into mu n plus p into q into mu p. Under minimum condition, what are the values of n and p? You please substitute now. So sigma minimum is nothing but n value we got. I got n value. N equal to ni into under root of mu p by mu n. I got mu p by mu n into q into mu n. Plus, what about p? P is given here now. P equal to ni into under root of mu n by mu p. Mu n by mu p I can put into q into mu p I can put here now into mu p only. That value we got. On simplification, sigma minimum is nothing but ni into here root of mu p I am getting here into q into root times I can cancel root of mu n I can get root of mu n plus ni into root of mu n here q into root times of mu p we will get now. And final value is nothing but this is the minimum conductivity. So ni both ni into q into root of mu n mu p here plus ni into q into root of mu n mu p here also. Finally I can write sigma minimum is nothing but this is the formula 2ni into q into root of mu n mu p. This formula you must apply for minimum conductivity. Sir, in the GID exam, the derivation is very lengthy. I cannot muck up, sir. Sir, I cannot derive, sir. If you are unable to derive, means you muck up. You must muck up. Minimum conductivity equal to 2 into Ni into Q into root of mu n plus mu n into mu p. But you must know here, understand now. You must know this formula. Without knowing this formula, we can't get answer. Understand my point? You must remember this formula. Sir, I cannot mug up this formula, sir. You must derive only. You must derive only. No other way. Understand? Now I can substitute what is sigma minimum here. I want to find sigma minimum. 2 into Ni. What is Ni here? What Ni is given? Intrinsic concentration Ni is given 1.5 into 10 power 10. 1.5 into 10 power 10 is given. Q we know very well. 1.6 into 10 power minus 19 you know very well. Under root of mu n into mu p is possible. Mu n, sorry, plus only possible. Sorry, correct. Addition is made, is not. Root of mu n mu p. Mu n equal to how much here? Mu n is nothing but mu n is 1350. 1350. 1350 into mu p value also required. What is mu p value? Check it now. Mu p is 495. 495 only I can put. Sorry. 495. It is given clearly. 495. Use calculator and 5 and get your answer now. What answer you'll get? Anybody getting answer for this question? Any student is getting answer for this question? It comes as 3.92. 3.92. 3.92 into 10 power minus 6. 10 power minus 6. Units are mho per centimeter. It is possible. Mho per cent. 3.92 into 10 power minus 6. 495 is correct. 495. Yes, correct. Yes, this is the answer for this question. So minimum conductivity is calculated by this particular formula. Understand my point? Yes, you try. I will give one more question in your hand. You start doing this question without my help. I'll see how many students can do this question. I want to see how many number of students can do this problem. Any student can get answer for this question? Yes, it is given 3 scattering mechanisms exist in a semiconductor. 3 scattering mechanisms. If only the first mechanism were present, the mobility would be 550 cm square per volt second. Only one mobility is present means 550 cm square per volt second. If only the second mechanism were present, the mobility would be 700 cm square per volt second. If only third mechanism were present, the mobility would be 1450 cm square per volt second. The net mobility equal to how much is asking? That means the mobility of the charge carriers here depends upon the different mechanisms only here. If only one mechanism is existing, what its mobility is given. Second one is mechanism is existing means what is the mobility. Third mechanism is existing means what is the mobility. Finally, overall mobility, how much is possible is asking here. I will give now. It's given like this. It's a very simple question. The mobility in the first case, it is given mu1. Mu1 is given as a 550 cm square. 550 cm square per volt second, it is possible. Per volt second. If only second mechanism were present, you will get the mu2 value. The mobility would be 700 cm square. 700 cm square per volt second is possible. The second mobility only exists, second mechanism only existing means now. The mobility would be how much? 1450 if it exists. Third mechanism, mu3, that is given 1450 cm square per volt second is given, per volt second. And finally is asking the overall mobility, total mobility equal to how much? Mu t is asking to find. How we can find the total mobility? The different mechanisms, because of the three different mechanisms, if you got the three different mobilities here, no total mobility, how to calculate means this formula is applied generally. 1 by mu t equal to 1 by mu1 plus 1 by mu2 plus 1 by mu3. This the formula is generally applied. Generally applied formula is this only totally. If it is existing the more than 3 means you can extend also this now. Understand now. You can substitute every one of the value here now. I can substitute like this now. 1 by mu t is required. Overall mobility is required. 1 by mu1. Mu1 is given 550 here. 1 by mu2 is nothing but 1 by 700 it is given. 1 by 700 plus 1 by mu3, 1 by 1450. 1 by 1450 is given here. Now you find what is mu t value. What is mu t value here required? The mu t value comes as 254 point. If you are using the calculator, it comes 254.038. 038 cm square per volt second. Cm square per volt second, I can say. The volt seconds for cm square per volt second. This much value possible if you are using calculator. I think you followed this. And I wish to give you one more question here now in your hand. You please tackle this question without my help again. Without my help, you complete this. Anybody can find this value? Anybody can do this? Yes, the problem is given. The DC current gain beta of a BJT is 50. Assuming that emitter injection efficiency is 0.995. The base transport factor is dash, up to 3 decimal places it is required. How you can determine? In this particular problem, it is given beta. Beta is given clearly. That is given 50. Is the beta value. Given clearly. Emitter injection efficiency is given a symbol gamma asterisk, I said already. Gamma asterisk is given as a 0.995. 995. It is given in the problem. Base transport factor is nothing but, I gave already, Beta asterisk I gave it already. Beta asterisk is given. Base transport fact. What now? Base transport factor only is asking now. Beta asterisk is asking. That is the base transport factor is required. Beta dash is required. Base transportation factor is required. Understand? Otherwise you can write gamma is nothing but emitter. This is emitter. Emitter injection efficiency. Injection efficiency given. Efficiency given. Beta dash, I want base transportation factor. Base transport factor is given. But how I can find the beta, how I can find the base transport? We know very well. Base transport factor equal to, already done. Base transport factor is nothing but alpha by, I gave already, emitter injection efficiency. Emitter injection efficiency. Emitter injection efficiency. That formula, that all I alpha equal to gamma asterisk into beta asterisk already given. Just in what now sentence I gave it here now. Then base transport factor is nothing but alpha is required. Without alpha I cannot get. Beta is given in the problem. So you can determine alpha. Alpha equal to beta by 1 plus beta. Beta is given 50, 1 plus beta becomes 151 only now. What is alpha value here now? Alpha value becomes 0.98. 0.98. Then you can determine base transport factor. You can determine base transport factor. Base transport factor is required. Alpha by 0.98 by emitter injection efficiency. Emitter injection efficiency 0.99995. If you are using the calculator, you will get 0.98 up to 3 decimal places is given. 0.985. 985 is possible. This is base transport factor against it. Such a way you can calculate. And I want to give one more question. You please try this now. Yes, you start doing this question. You can try this question without my hand. Yes, this problem you can. Please tackle this question without my help. An N-type semiconductor having uniform doping is biased as shown in the figure. That means N-type semiconductor is connected by the external source. If EC is the lowest energy level of the conduction band, EV is the highest energy level of the valence band, and EF is the Fermi level, which of the following represents the energy band diagram for the biased N-type semiconductor? Which is the right energy band diagram? If N-type extrinsic semiconductor is connected by the external source, it is given here now. External source, if it is given, which energy band diagram is to be taken? That's more important. But we know very well, but how we can do this question, you please watch, you can understand. If it is an N-type extrinsic semiconductor, you know very well. The diagram it is taken. When the supply is not given, without supply, without external supply, external supply. How the shape of energy band diagram that I want to plot here now. This is nothing but the EC, conduction band energy. EV is taken here, valence band energy is taken here now, EV. I can say here the Fermi level is going to lie very close to the conduction band. In the n-type external semiconductor, everybody knows. It lies close to the what now? Conduction band only. This is said to be the Fermi level. In the n-type external semiconductor, EF or EFN allowed only. But if the supply is connected, as shown in the figure, is connected, as shown in figure, what happens we can see. If it is connected supply, what is going to happen? But in this case, the supply, whenever you connected here now, polarities you watch. How the polarities are given here. You please watch. Negative electrode it is. This is nothing but the positive electrode, you know very well. The negative is connected to this side. Positive is given to this side one. For the n-type extrinsic semiconductor, negative is given to that side, positive will be connected to this side. That means this side we are taking negative. This side we are putting the positive only. You know very well how the direction, when the supply is given, what happens now? Negative polarity here. The liberation of the electrons in the semiconducting material, will try to move from valence band to conduction band. The electrons will try to move in this particular direction. Valence band to conduction band, they will move. Catch my point, very simple way I'm explaining here now. Because the negative indicates negative is this side. At the time you have to assume electrons will move from this side to this side. Negative means electrons move this side. This side positive, how holes are going to move? When the supply is given, holes will try to go down only now. Holes will be what in the valence band it is going to increase. It goes down. Electrons increasing in the conduction band. The holes will be increasing down only now. As a positive indicates, holes will try to go down this side. So based upon this arrow you must draw. That means this is tilted, this energy band diagram, because of the connection of the supply. That means this point, this line will go to top. This will try to move to top. This will try to come down only now. At the time diagram will come like this. This is going top, this is going down because of the positive polarity. And this will go down like this. Tilting is done such a way only now. In that case, this Fermi level also changing like this only now. It comes in this way. This is EF, this is EC, this is EV, no doubt. Such a way it comes only now. The diagram it comes. Finally, this is said to be energy band diagram. This is the energy band diagram after the application of the supply. In that case, which option is correct? Option D is correct in this particular problem, I can say. Which option is correct in this particular problem means option D is correct only, we can say. This option is correct only, we can say. This option is correct in this particular problem. Just I want to give the information regarding the IMS Gate Academy. The students can put some concentration on it also. But in the IMS Gate Academy Telegram channel it is. The students are willing willing to join in this Telegram channel, sure, they can join. It's a free of cost, no need to pay single paise only now. Directly they can join our Telegram channel. And also not tomorrow, today also you can join. Because of this Telegram, because when you join in the Telegram channel, what are the benefits you will get now? Schedules of the free YT lectures. The IMS Get Academy conducting number of YT lectures, YouTube lectures. What are the dates, what are the timings, and everything will be posted in the Telegram channel. The students can get idea. And they can watch the these YT lectures. Lectures PDF also possible to get now. So I took the class here now. Once the class is over, PDF for this lecture will be taken and posted in the Telegram channel. The students can watch number of times these questions, and also they can solve, they can cross-check with their with these solutions. PDF file, if you got means, just like a notes you will have. The important updates related to the seminars and webinars also given in this Telegram channel. And the PSU and other government job notification also given in this Telegram channel. Expert sessions on important topics, daily quiz, and many more. Daily quiz means the faculties are going to post questions on different branches and different subjects. And students can solve the question, they can post. If they are unable to solve this question, they will get the solution also for that question now. Understand now? The practice of problems can be done every day because of this quiz only, we can say. It is the main advantage of this Telegram channel. Next ones. The students who wants to take admission for the GATE 25 and 26. Here given. Program Futures of IMS GATE Academy. The student is willing to take the admission in IMS GATE Academy, they will be benefited. What way they will be benefited? 800 plus hours of live classes with live interactions possible. Live online program this one. 800 plus hours of live classes with live interaction. But IMS GATE Academy providing to the students theory book, exercise books, and 30 plus years GATE question banks with video solution. That means what now? Number of problems are given in the exercise books. Solutions also given. The students can practice each and every one of the problem. If they are getting any doubt, immediately they can cross-check with the solution only now. And 30 years GATE questions bank is given. 30 years now. So many questions are given. They were all solved, and also for important question, video solutions also given here now. 12 personalized one-to-one mentorship sessions. Mentorship session also possible now. Where 12 personalized one-to-one mentorship session now. Here, the faculties are going to motivate the students. The faculties are going to explain the study plan, how to do. Everything will be given in this one-to-one mentorship now. 130 plus online tests with video solutions of the mock test and many more. The students are going to prepare for the examination, and they will get a doubt, my preparation is a proper or not. At the time, how they can check? They need to write number of online tests. They are writing the number of online tests, they can understand where there is a problem, where they are facing the problem. And they can easily correct that. That is why online tests are also conducted by the IMS GATE Academy. So if you want to get any information clearly, you can make a call to this number. They will respond, they will clarify your doubts, you take the admission and get benefited. Thank you. These are the information, these are the problems are possible for today's class. Thank you all.